it's time for us to start talking about default routes. Default routes, irregardless of what routing protocol we're employing, whether it's going to be EIGRP, OSPF, RIP, the idea of having a default route is going to be very, very handy, especially if we want to be able to afford our users internet access. Because remember, the default route is going to be where we send traffic that we don't have a more specific prefix to match. Now, the idea is that in the context of RIP, we have the capability of originating these default prefixes. Now, what I'm going to do is I'm going to go to R1 and I'm going to create a default prefix. So over on R1, config T, router RIP, what I'm going to do is I want to modify this such that it's going to create a default route. And I'm going to use the default -information originate command to be able to do that. Now, I'm going to just go ahead and hit enter. Now, what we're going to do now is let's take a look and see what's going on. So if I come up to any of these devices, do show IP route, notice here I have no gateway of last resort that's being set. Now let's go up to R2 and see what happens on R2. Show IP route. Now I do on R2. I'll find one on R4. Do show IP route, default route. Should even find one all the way over on R22. Show IP route. And I'm going to see I have a gateway of last resort, learned via RIP, and here I have two different ways to get to it. So basically we have everything in our infrastructure set up such that it's advertising this particular default prefix. Now, what I want to also understand or realize here is that what happens if I wanted to change this behavior. Let's take a look at what's happening. On R1, I'm originating a default route. That default route is being propagated to all devices. Ultimately, it's reaching R22. R22 is operating under the assumption that it can load balance to reach that particular prefix, so that interface. The issue is, unlike other routing protocols, RIP is not creating or does not necessarily have to have that prefix configured. So if I type show IP route, what we're going to find is the gateway of last resort is not set, nor are we going to have a static route of all zeros configured on this device. Now, obviously, I could create a manual prefix for this, but I'm not going to do that right now. I want to just leave this the way it is, and we want to look at how we're propagating information, because R1 is advertising all of these prefixes. Now, what would happen if I wanted to do a manipulation on, say, R2 or R3, such that R22 would only use one of those routers, R2 or R3, to reach this default route. Now, we've played around with the idea of a distribute list. Now, what I want to do is I want to do the exact same scenario here where we use this distribute list. And what I'm going to do is when I'm done, R22, show IP route 00000, is going to use, let's say, serial 2/1 to reach that destination, which means I need to block the advertisement of the default prefix to R22 across S2/1. Sorry, S2/0. I want to prefer this link to be able to reach this default route that R1 says that it's originating. Now, the way I'm going to do that is I'm going to, again, employ a distribute list. This time, however, I'm going to do it out. We did a distribute list configuration previously, but I did everything inbound. So now what I want to do is I want to distribute what I'm using a distribute list to control what I advertise out. So what I'm going to do is I'm going to stop R2 from advertising that default route. So let's go over to R2 and do that configuration on that individual device. Now, what I need to do is I need to create a prefix list. So again, I'm going to use prefix lists to make this happen. So show IP prefix list. They're all removed from R2. And what I'm going to do is I'm going to say I do not want to send a default route out. So config T, IP prefix list. And what I'm going to do is I'm going to say no underscore default. And what I'm going to do here is I'm going to say specifically, say sequence 10, I'm going to say deny the network of all zeros /0. Now I'm not going to use a less than or equal to in this scenario, but I do need to go in and do a permit because I don't want to block all traffic. And anytime I do a permit for all traffic, it needs to be less than or equal to 32. So now what I want to do, let's see, same policy. Sequence, excuse me. Do show IP prefix list. All right, we're good to go there. Finally took. Now what I'm going to do is I'm going to go to router RIP. Now what I want to do here is I do not want to advertise this default network out. So what I'm going to do is I'm going to say distribute list. And I'm going to say no underscore default out specifically serial 20. All right, let's cut over to R22 real quick and make sure we've got what we want. Notice my show IP route told me that I can use both R3 and R2 to reach this default route. Now let's see what happens now. Show IP, let's just go ahead and refresh this command right here. Well, look here, 46 seconds. Anytime we see anything over 30, we should become suspicious. Anytime we see anything over 60, we know we've got a problem. But as I'm saying, in this scenario, the problem that we have is the problem that we want. What's notice is that on serial 20, this is going to actually expire out of our routing table, and we're going to rely on our link to R3 via serial 21 to reach this default prefix. So what I've illustrated here is the fact that I can generate a default route, and I can also manipulate how that default route is going to be advertised and to whom it's going to be advertised on a hop-by-hop basis throughout my infrastructure. Let's see what happens now when this thing is done. Show IP route. Let's see. Well, now it's refreshing. Show IP route. Well, according to this, it refreshed. So we have via serial 21, via serial 20. I have the updates. Let's see what's going on R2. Show IP prefix list. We are denying this one, and we're permitting everything else. Show run section router. Out serial 20. Show CDP neighbor serial 20. That's going to my data center. That's all correct. Show run section router. And it is out. So no default. Did I spell it properly? No underscore default. No underscore default. Seems to be good to go. Show IP route. There it is, my gateway of last resort. So let's go back over to R22 and see what's going on. Well, this still tells me I'm learning it. And I'm learning it from 2. Clear. clear IP route star. Clear IP route star. Clear IP route star. Show IP route. Still says it's there. So that syntax doesn't seem to be working. Make sure that I didn't mess up. Show IP prefix list. Oh. On R2. So I'm denying the default route, and I am permitting everything else. Distribute list, no default, out that interface. It should not be being advertised. Show IP route. And it is. Two 1, 2-0. It is being advertised. You see what I did? Syntax is a bear. What did I use to match the network? I used a prefix list. I used an IP prefix list. What I did is I did a distribute-list, no default. But when I use that syntax, let's look and see what the system is actually expecting there. Router, RIP, distribute list. And if I use an enter, it's using a named access list. So the problem is I did not configure, I configured my IP prefix lists correctly, but I didn't apply them correctly to my process. So what we need to do is we need to eliminate this config, do show run section router. So I'm going to grab the distribute list, I'm going to say no, and take it completely out of the equation. Now what I need to do is use the prefix keyword. So all I'll come in here is say distribute list prefix. No default out serial 2/0. Do clear IP route star. Now let's cut over to R2 and see what's going on. Let's repeat the command for the show route. Notice 47 seconds. Let's see what happens. 52 seconds, and we'll wait for it. 56 seconds. 59. Are we going to go above 60? Yes, we went over 1 minute. So now what I'll do is I'll clear this out. Clear IP route star show IP prefix list show IP route RIP. Now we only have one prefix and we only have one interface that we can use to reach it. And we can wait forever. And it's not going to come back because the prefix command is actually filtering the advertisement outbound using the distribute list. So the distribute list is not only to affect what's coming inbound, it can also be used to affect what's outbound. That's why I refer to it as being a directionally configuration command. Now, a lot of mistakes are stupid mistakes. You go in, you just start typing, and you leave out a simple keyword, and nothing works the way you want it to. And you need to understand exactly how to backtrack through your process to find these mistakes and these errors and issues. So again, if I make the mistakes in front of you, you guys are aware of them. Some of them are actual mistakes, some of them aren't mistakes. It's just the idea of making certain that we get to exposed and we get to see the output and the results of as many different configurations as humanly possible. I highly recommend that you guys utilize these particular commands in your own labs, practice them, because this is the type of question that Cisco is going to ask you regardless of what routing protocol you're working with, whether it's going to be EIGRP, OSPF, BGP, or something as simple as RIP. So with that said, what we'll do is we'll dive in and we'll look at another aspect of being able to do filtration, and excuse me, not filtration, but the idea of our default prefixes in the next video. See you there. Bye-bye.